All right, so let's look at the definition of sample space. This is the very beginning and the basis of probability. So the sample space is the set of all possible elementary outcomes of an experiment. So when we say a set, we mean a group of numbers, usually. A sample space is denoted with a capital letter S, right, which is kind of what I've annotated here. So here are some examples of experiments and the resulting sample spaces for those experiments. So if we were to flip a coin as an experiment, then what would be all elementary outcomes of flipping a coin? Well, we could get a heads or we could get a tails. So our sample space for a coin toss is going to be composed of heads and tails. And so notice that I've got this capital S, which is the variable that represents the sample space, and that's equal to this set of things. And so usually sets are denoted with curly braces. And inside the curly braces, we have each element of the set. And so here we've got two elements, H and T, or two outcomes. Now, if we look at the experiment of rolling one six-sided die, then the sample space would be the result of 1, 2, 3, 4, 5, or 6. And that's just the number of pips that are on each side of a six-sided die. Now, what if for an experiment, we rolled two six-sided die? And so what would be the sample space for two six-sided dice? That would be a result of snake eyes, two ones, all the way up to two sixes, which would be 12, and everything in between. So in this think, pair, share, maybe, pause the video and give some time to think of some examples of an experiment and then define its sample space. So go ahead and pause, give it some thought, and then come back and I'll share with you some examples I thought of. Okay, so one example, I suppose, I guess you could think of it as an experiment. So if we look at the life expectancy of humans, what would be all possible outcomes? Well, we can have 0 years old to 1, 2, 3, and so on, up to, maybe the oldest. I'm not really sure what the oldest is, but it would be something like that. So this would be what the sample space would look like for life expectancy of humans. How about the sample space for 3 coin flips? So what if you were to flip 3 coins at once? Well, all 3 coins could come up where each of them is heads. You could have 2 out of the 3 being heads, in which case you could have any of these combinations, right? The first 2 dice would be heads and the third one would be tails. Or the first and the third one are heads and the second one is tails. Or the first coin was tails and the last 2 were heads. Or you could have, instead of having 2 heads out of 3, you could have 1 head out of 3. So let me put one more. Oh, that's right. That's right. Tails, tails, heads. There we go. And then maybe the last elementary outcome of 3 coin flips would be no heads at all, something like that. So remember the sample space, what it represents is it represents all possible outcomes of a random experiment. Now let's look at the definition of an event. So an event is any subset of the sample space. And so we denote an event usually with a capital letter, and it doesn't always have to be E, right? I'm just using E because, the word event starts with an E. But we could use any other letter of the alphabet to signify a particular event. And this symbol, which looks like a U on its side with a line underneath it, this means subset. And so what this means is that E is a subset of the sample space. So if an outcome of an experiment is contained in E, we say that the event E has occurred. So let's look at some examples of events. So the first example, we'll just keep it simple with a coin toss experiment. So our experiment is a coin toss. The sample space would be all of the elementary outcomes of a coin toss, and that would be a heads or a tails. And we're just going to arbitrarily define an event to be the event of getting a heads. And so this would kind of lead you to calculate maybe the probability of the event, which is the probability of getting heads. So when an event contains a single elementary outcome, we call the event a simple event. So because this event has a single elementary outcome, we would call this one particularly a simple event. Now this next example, we're going to choose as an experiment rolling one six-sided die. So the experiment is the die roll of one six-sided die. The sample space for a six-sided die would be 1 pip all the way up to 6. And now we're going to define the event to be any even number. And so any even number could be a 2, 4, or a 6 result. So now we have an event that isn't composed of one elementary outcome. What we've got here now is we have more than one elementary outcome. And that's what makes this a compound event. So the way that we've defined event E is that it's composed of more than one elementary outcome. So this is a compound event. And notice that what would be some other even numbers, right? Some other even numbers would be like 8, 10, 12, 14, and so on. So how come if we defined event E to be an even number, why aren't these numbers inside this event? Okay, they're clearly not. I've only got 2, 4, and 6 in here. It's because the event is limited to your sample space. So these numbers, which are even, 8, 10, 12, and 14, those are not numbers that are inside your sample space. They're outside of it. Okay. All right. Next, you're going to hear me talk about the order of a set or of an event. And I use these vertical lines, a pair of vertical lines, to denote the order of. Um, you know, do not mistake when I'm talking about the order of an event, because this looks like absolute value in algebra. Okay, so don't mistake it for absolute value in algebra. This is just a similar symbol, but it has a different connotation when we're talking about probability and when we're talking about sets. So what does the order of a set or an event mean? It's the number of values or items that are in a set or event. It's the number of elementary outcomes in the sample space or an event. So if we have these vertical lines, these vertical bars written to either side of the capital letter S, what we're saying is the order of S, the order of the sample space. And if we've got two vertical lines around an event, then we want to know what's the order of the event. What's the order of event E? So let's look at an example here. So let's look at the order of the sample space. So if the sample space is composed of the sample space of a six-sided die, then what's the order? Well, let's look at all of the elementary outcomes that are on a six-sided die. We've got 1, 2, 3, 4, 5, and 6. How many elementary outcomes do we have inside of the sample space? Well, we've got 6. So the order of the sample space is 6 because there are 6 items or outcomes in the sample space. All right, let's look at this next example. So this is a think, pair, share. So you could pause the video here and try this on your own. All right, but instead of trying to figure out the order of a sample space, now we're trying to figure out the order of this event, event E. All right, so if our sample space is one six-sided die and event E is going to be an odd result, let's go ahead and let's put down our sample space. Okay, and event E is an odd outcome. Well, what odd outcomes do we have in our sample space? We have 1, 3, and 5. 1, 3, and 5. And so what's the order of E? How many outcomes do we have in our event? We have 1, 2, 3. So the order of the event is 3. Okay, let me know if you have any questions.